Welcome to The Explainer. Today, we're going to pull back the curtain on a type of AI that, believe it or not, thinks a lot like we do. We're going to get right inside its head to see how it makes decisions. Decisions you can actually follow, and most importantly, question. So, let's start with a really basic question about something you do all day, every day, probably without giving it a second thought. How do you yourself actually make a decision? I mean, think about it. You're not running some complex formula in your head. Your mind it navigates the world using a whole series of simple, branching yes or no questions. Like, is it raining outside? Yes. Okay, I'll take an umbrella. Is this a big meeting? Yes. Right, I'll wear the nice shirt. It's just one little logical fork in the road after another.
Now, here's where it gets really interesting. One of the most powerful and frankly most intuitive AI models out there, the decision tree, works in pretty much the exact same way. It learns from a whole bunch of data to build its very own flowchart of questions to get to an answer.
And you can actually map it out. It has this really clear anatomy, just like a tree. It starts with one single really important question at the top. That's the root node. That first question splits all the data. Then you have the branches, which are the internal nodes. These are just more questions that slice and dice the groups even further. And it all ends at the leaf nodes, which give you the final answer. Approved, rejected, spam, not spam, whatever it might be.
All right, let's make this real. Imagine a bank is using a decision tree to figure out whether or not to approve a loan. The stakes here are obviously pretty high, so being able to explain why a decision was made is absolutely critical.
So the tree might look at thousands of past applications and learn that the very best question to ask first is, has this person ever defaulted on a loan before? If the answer is yes, it sends them down one path. The next question might be, is their debt-to-income ratio over 70%? If that answer is yes, it leads right to a leaf node, reject loan. The entire chain of logic is laid out clear as day.
And that right there is the million-dollar question. I mean, out of all the things it could ask about, income, age, the loan amount, debt, how does the machine figure out, mathematically, which question is the best one to start with? The one to put at the very top, at the root of the tree?
Well, the answer comes down to this idea called impurity. Just think of impurity as a measure of how messy or mixed up a group of data is. The tree's main goal is to find the one single question that will split a messy group into two new groups that are as pure as possible. And by pure, we just mean groups where everybody inside has the same outcome.
So picture our initial pool of loan applicants. Let's say it's a perfect 50-50 split. Half of them were ultimately approved, half were rejected. In data science speak, this is a state of maximum impurity. It's totally chaotic. A prediction from this point is no better than a coin flip.
Now, to actually measure this messiness, the model uses a nifty little formula called Gini impurity. You don't need to be a math whiz to get the idea. It basically calculates the odds that you'd mess up if you randomly labeled an item from the group. A Gini score of 0 means perfect purity, everything's the same, you can't be wrong. A score of 0.5, like our 50-50 mix, means maximum impurity, total chaos. And this is the entire game. The algorithm literally tests every single possible question it could ask. For each question, it calculates the Gini score of the two new groups it would create. And then, it just picks the question that causes the biggest drop in impurity. The one that does the best job of turning one big, messy group into two much cleaner, more predictable ones.
Now, Gini is super common because it's fast for computers to calculate, but it's not the only way. There's another method called information gain, which is based on a concept from physics and information theory called entropy, basically a measure of randomness. The goal is the same: find the question that gives you the most information, the one that reduces uncertainty the most. And honestly, most of the time, both methods end up picking the very same question.
So all this math about splitting data and reducing impurity, what's the real payoff? It gives us something incredibly valuable, something that goes way beyond just getting a yes or no answer at the end.
It gives us a ranked list, a scorecard of what actually mattered in the decision. By tracking how much each feature, like prior default or annual income, helped to reduce impurity, the model can tell us exactly which factors were the heavy hitters. You can see right here, having a prior default was, by far, the most important factor. For a business stakeholder, this is absolute gold. It proves the model's logic is sound. And this kind of transparency isn't just a feature of decision trees. They're part of a whole family of what we call interpretable models. You have even simpler things like rule-based models that don't even bother with the tree diagram. They just give you a plain English list of if-then statements.
Like, if a person has a prior default and their debt ratio is over 70%, then the outcome is reject. It doesn't get much clearer than that.
And that's really the key. This ability to see the logic is what makes these models so powerful. That ranking of what matters, it's intelligible, right? You can understand it. It's auditable, you can check it for fairness and compliance, and it's actionable. You can actually use that insight to improve your business. The reasoning is right there on the table for everyone to see and to challenge.
So, when you get right down to it, this isn't just about some elegant math. This is about building trust. Trust between us and the automated systems that are making more and more critical decisions about our lives, from our money to our health. It's about making AI accountable.
Which leaves us with a final question to chew on. When an algorithm has this kind of power, this much influence over our world, isn't the ability to understand its reasoning more than just a nice feature? Isn't it a basic right? If an AI makes a decision about you, shouldn't you be able to ask it why?